Food Safety Enhancement Program Manual and its forms. So FSEP is a systematic approach to identify and control food safety hazards. It's based on HACCP system. HACCP is a globally recognized system and it is used as a benchmark in the FSEP. Let's compare these two concepts. HACCP is like the foundation of the house, providing the basic structure and principles, and the FSEP is like the house itself, built on the HACCP foundation, but with additional elements tailored to the Canadian context. Now let's look at some real-life examples. Think of a bakery. The HACCP system would identify potential hazards like flour contamination or improper baking temperatures. The FSEP, on the other hand, would provide a detailed plan on how to manage these hazards, including specific procedures for the Canadian bakery. And for a meat processing plant, the HACCP might identify cross-contamination from raw to cooked meats as a hazard. FSEP would then provide guidelines on how to prevent this, such as separate processing areas or specific sanitation procedures. And in dairy product, HACCP would identify pasteurization as a critical control point. The FSEP would then provide a detailed plan on how to monitor and record pasteurization temperatures and times, ensuring the milk is safe for consumption. And the FSEP manual includes 11 forms, which are designed to help food establishments implement a robust food safety system. These forms covers everything from product description and hazard identification to process flow diagrams and control measures. And if you want to look for potential hazards, you can look it up in the reference database for hazard identification. So let's kick things off with Form 1, which is all about product description. This form is where we provide a detailed description of our product, including its intended use, packaging, shelf life, storage conditions, and more. Think of it as our product's ID card. It tells everyone who needs to know exactly what our product is, what's in it, and how it should be handled. Let's illustrate with some real-life examples. Let's say we're producing a type of cheese. Our product description would include details like the type of milk used, the cheese making process, the type of bacteria or mold used, the aging process, the type of packaging, and the optimal storage conditions. And if we are a brewery, our product description would include details like the type of beer, the ingredients like malt, hops, yeast, and water, the brewing process, the alcohol content, the type of packaging like bottles, cans, or kegs, and the shelf life. For bakery, the product description would include details like the type of bread, the ingredients like flour, yeast, water, and salt, the baking process, the type of packaging, and the shelf life. A clear and accurate product description is the foundation of food safety and quality assurance programs. It helps everyone involved in the production process understand exactly what they're working with and how it should be handled. Okay, let's move to Form 2. This form is all about the ingredients and materials that go into your product. It's like the guest list for all the guests in your town. So Form 2 requires you to list all the ingredients and incoming materials used in your product. This includes everything from the main ingredient to the smallest additives. Suppose you are running a bakery. Your Form 2 for loaf of bread might include flour, yeast, salt, sugar, and water, but it doesn't stop there. You also need to consider incoming materials like the packaging for your bread or the oil used in your baking pans. And for a meat processing plant, their Form 2 might include different cuts of meat, spices, and casings for sausages. They also need to consider packaging and any materials used in processing, like food-grade lubricants for their machinery. And for a dairy factory, their Form 2 could include milk, cultures for yogurt, fruit for flavored products, and so on. They also need to consider materials like bottles and cartons for packaging. Moving to Form 3, we have process flow diagram. This is like the roadmap for our product. It shows every step your product goes through, from receiving ingredients to shipping the finished product. Let's go back to our bakery example. Your process flow diagram might start with receiving ingredients, then move on to mixing, proofing, baking, cooling, packaging, and finally shipping. And for a meat processing plant, their process flow diagram might start with receiving raw meat, Then move on to cutting, grinding, mixing with spices, stuffing into casings, cooking, cooling, packaging, and then finally shipping. And in a dairy factory, the process flow diagram could start with receiving milk, then moved on to pasteurization, homogenization, adding cultures for yogurt, incubation, cooling, packaging, and then finally shipping. So this process flow diagram is like your product's personal GPS. It shows you where you are going and helps you stay on track. Okay, form 4, plant schematic. It's all about the layout of your plant. It's like the blueprint of your house, showing you where everything is located. This includes everything from processing equipment to hand washing stations. For our bakery example, your plant schematics show where your ovens are located, where your ingredients, where you package your bread, and so on. And for a meat processing plant, their plant schematic might show where they receive and store raw meat, where they cut and grind the meat, where they cook and package their products, and so on. And in the dairy factory, the plant schematic show where they receive and store milk, where they pasteurize and homogenize the milk, where they add cultures for yogurt, where they package their products, etc. Okay, form 5 is all about identifying biological hazards. These are the nasty little critters like bacteria, viruses, and parasites that can make people sick if they get into your food. In a bakery example, biological hazards could include things like salmonella in raw eggs or E. coli in contaminated flour. And for a meat processing plant, their biological hazards could include things like E. coli in raw beef or Listeria in ready-to-eat products. And in dairy factory, biological hazards could include things like salmonella in raw milk or Listeria in soft cheese. Moving to form 6, we have chemical hazard identification. This is all about the chemical hazards in your process. This could include things like cleaning chemicals, pesticides, or allergens. In a bakery example, chemical hazard could include things like cleaning chemicals getting into your dough or undeclared allergens in your ingredients. For a meat processing plant, their chemical hazards could include things like antibiotics, residuals in raw meat, or undeclared allergens in their spices. And in a dairy factory, it could include things like cleaning chemicals getting into the milk or undeclared allergens in flavored products. Okay, form 7, physical hazard identification. These things are like metal shards, glass pieces, or even stones that could potentially find their way into your product. In bakery example, physical hazards could include things like a piece of broken mixing blade getting into your dough or a piece of plastic from packaging materials. For meat processing plant, it could include things like bone fragments in ground meat or metal shards from a broken grinder blade. In a dairy factory, physical hazards could include things like pieces of a broken milk bottle or a piece of a broken pump seal. Okay, form 8 is where we use the decision tree to determine our critical control points and other control measures. A CCP is a step in your process where a hazard can be controlled or eliminated. In bakery example, a CCP might be the baking step where harmful bacteria are killed by heat. In a meat processing plant, their CCP might be the cooking step where harmful bacteria are killed by heat. In a meat processing plant, their CCP might be the cooking step where harmful bacteria are killed by heat. And also for a dairy factory, right? CCP could be pasteurization step. Okay, form 9. So form 9 is about hazards that are not controlled by the establishment. This could be hazards that are controlled by the customers or the suppliers or the consumers. In a bakery example, a hazard not controlled might be improper storage of bread by a consumer, leading to mold growth. Or in a meat processing plant, a hazard not controlled by the establishment could be undercooking of meat by consumer, leading to foodborne illnesses. And in a dairy factory, it could be the improper refrigeration of milk by consumer, leading to spoilage. Okay, let's move to form 10. We delve into the realm of critical control points, or CCPs for short. These are the steps for your process where you can control a hazard. In a bakery, one of their CCPs could be cooking step. They need to ensure that their bread reaches a certain temperature to kill all potential salmonella in the raw eggs used in the dough, right? And in a meat processing plant, their CCP might be cooking steps as well, but they are controlling for different hazard, E. coli. They need to ensure the meat reaches a certain temperature to kill any potential E. coli. And in dairy factory, the CCP could be the pasteurization step. They need to heat the milk to a certain temperature to kill any potential listeria. And let's go to the last form, Form 11, which is all about process controls. These are measures that are put in place to control hazards that are not controlled at a CCP. Let's look at a brewery. For example, they might have process control for the fermentation step. They are not controlling a food safety hazard, but they are controlling the alcohol content of their beer. If the beer doesn't ferment long enough, it might not have the right alcohol content. And for a candy factory, they might have a process control for the cooking step. They're not controlling a food safety hazard, but they are controlling the hardness of their candy. If the candy doesn't cook long enough, it might not harden properly. And for a coffee roastery, a process control could be roasting step. They're not controlling a food hazard, but they're controlling the flavor of their coffee, right? If the coffee doesn't roast long enough, they might not have the right flavor. And in our bakery example, it could be the temperature and humidity controlled in the proofing step to prevent overgrowth of yeast. And for a meat processing plant, their process control might be the chilling step after cooking to control the growth of bacteria. And in a dairy factory, it could be the temperature control in the fermentation step to control the growth of bacteria. This brings us to the end of our journey through the Food Safety Enhancement Program Manual. We've covered a lot of ground today, from the importance of product descriptions and ingredient lists to the intricacies of hazard identification and control. So that's for today's video. See you next time.